Welcome back, and thank you for joining us. Once again, it's Open Infra Live, the Open Infrastructure Foundation's weekly hour-long interactive content series where we share production case studies, open source demos, industry conversations, as well as the latest updates from the global open infrastructure community. This is our 7th episode, and we're focusing today on open source CI/CD. We have some amazing content coming up over the next few weeks, so please join us every Thursday at 1400 UTC for more Open Infra. I'm Jimmy MacArthur, and I'll be your host for today. We're streaming live on YouTube, LinkedIn, Facebook, and Twitch, and probably even MySpace. We'll be answering questions live throughout the show. We will also save time at the end, so feel free to drop questions in the chat, regardless of the platform you're on. We'll do our best to answer as many as we can at the end of the program. Today, we're here to talk about Zuul, a free open source CI/CD solution. I'd like to welcome our guests. First, some call him the godfather of Zuul. It's James Blair. He's the Zuul project lead and CEO of Acme Gating, offering expert support and consulting for Zuul. And the one and only Mohammed Nasser, CEO of Exos, where users can spin up their own fully managed Zuul. We'll have real-world business cases to discuss, plus a live demo, Dangerous, showing how to manage cross-project dependencies in production. James, I'm going to pass it over to you to get the ball rolling.
Thank you, Jimmy. Hi, yeah. So I'm James Blair. I'm one of the original authors of Zuul and the current project lead. And let's start with what is Zuul? Well, Zuul is a project gating system. And I can hear you saying, great, what's a project gating system? Well, the way I look at it is it's kind of the next step beyond CI and CD. So if you look at the history of continuous integration, if you go back to the first CI systems, CI stands for continuous integration. What were they doing? It was when you merged a change to, say, your Java project, you would run the build and you would see if it broke. And that was great. That was better than, say, finding out that it broke when you were releasing. But ultimately, that was focused on the past. We call that post-merge testing, and it's still a very relevant thing to do. But it's not really the state of the art in CI and CD at this point. Fortunately, since then, we've moved on to testing the present. And by present, I mean, this is what a lot of CI systems do now. They perform pre-merge testing. So this is, you write a patch, you push it up for review, and your patch gets tested as it was written, and you can find out if your patch is good or not. So we call that pre-merge testing, and it's like I said, it's focused on the present. For gating, for what Zuul does, it's really focused on the future. And by that, I mean, not only are we testing your patch before it merges, we're going to test your patch as it will be when it merges. So if the project has moved on since you wrote your patch, other developers are merging changes, that sort of thing, we're gonna merge your branch, merge your patch into a copy of the branch as it exists at that point. If there are other changes that are being merged around the same time, we're going to sequence those changes, and we're going to make sure that your patch works with all of the other patches that are in flight. So if you're in a relatively busy shop and you've got a lot of developers working on different things, you might have not thought to test all of those things together, but a project gating system needs to make sure that all of those things are tested together before it merges anything. And finally, an extension of this is something that we think is really neat. We call it cross-project dependencies, and that's the idea that you can indicate that your patch depends on some other patch, and the system will test those together. And that's actually the focus of our demo coming up later. So we're gonna talk about that a little bit more as we go on. So you might be wondering what prompted us to think that we needed to create such a complicated system. And to explain that, I'm going to talk a little bit about Zool's development history. So it was originally developed for the OpenStack project. And this project, this slide here, it has a bunch of logos that you may or may not recognize. These are actually logos of individual OpenStack projects. While we sort of put on this face for the world of, there is a thing called OpenStack and you can download and run it. That thing is actually composed of a rather large number of individual semi-autonomous projects. They have their own identity. They have their own logos. They have their own communities, which are all part of this larger community. So if that sounds like frankly, almost any enterprise, right? If every application these days has some form of this. We're not all just working on necessarily one monolithic thing. That every application sort of has tendrils that go out and little sub-projects and things like that. Anyway, we were presented with a situation of having all of these projects that needed to develop somewhat independently, but still work together at the end of the day. And so we needed to build a CI system that could handle that. And so that's sort of how Zool was born, with this idea of cross-project dependencies and gating. Since those days, those early days of developing Zool for the OpenStack project, we've actually, our community has grown. We have quite a large number of users now. These people are all using Zool, and there are many others as well. One thing that I think a lot of these folks have in common is that they have pretty large development efforts, and those efforts, once again, span large numbers of projects. So Zool does scale down. You can totally run it down for a single project. You can run it on. You can run the software on a laptop, and it can manage a single project just fine. But it also scales up really, really well. And so if you want to run a CI/CD project gating system for a community of hundreds or thousands of projects that are running at cloud scale, Zool can handle that very well. And we actually have a video from one of these Zool users from Volvo. So let's actually hear from them about how they're using Zool.
How are we running Zool? Well, we have a small core team continuous integration architecture that handles the Zool backend and the infrastructure. And we support up to around 111 developers who consist of many smaller teams, and they have at least one DevOps who can add nodes, pipelines, and repositories. And whenever a new team wants to use Zool, continuous integration architecture trains one of these people to become a DevOps. So why are we using Zool? Well, one of our developers said this in a really good way, and he believes that premium cars need premium tools, and Zool is a premium tool. And it forces us to have a green master, and in that way we increase our development speed. For example, the one-pedal drive of Polestar 2 was built with Zool.
So that's great. It's really exciting to see how Zool is being used in the real world with companies like Volvo. So I think one of the reasons why it's popular in organizations like that is this idea of multi-tenancy that is built into Zool. Again, when you have lots of teams, sometimes working together, sometimes working in isolation, it becomes important to sort of establish how they're going to work together. How does all this happen? How do all of the teams have complete individual control over the CI system, or do you sort of establish some parameters centrally and maintain central control? And with Zuul, we actually have a lot of knobs that we can turn to adjust that to exactly what the situation requires. So if you need, if your organization has really strict standardization, compliance, auditing requirements, you can turn that knob towards the towards central control, where all of the jobs and the workflows are managed centrally. Or if your developers need more freedom, you can turn that the other way and let developers in their own individual projects define their own jobs, pipelines, things like that. So there's actually a lot of flexibility in Zuul for dealing with that. And beyond that, we not only have this idea of having dependencies between projects, we also have the idea of dependencies between connections. We call those cross-connection dependencies. So Zuul supports several code review systems. Gerrit, GitHub, GitLab, Pagure, and more are in the works. And this isn't a case of just, oh, you can start up Zuul and point it at whichever one you're using. You don't actually have to pick one. Zuul will work with all of these systems at the same time. So if you're in an organization where one group of developers is using Gerrit and another group of developers is using GitHub, that's not a problem for Zuul. Zuul can talk to both of those systems at the same time, and those developers can actually express dependencies between their projects across those code review systems. And I've found in talking to large development shops that this is surprisingly common. So once you get a certain number of developers, you also get a certain number of opinions about the best code review system to use, and editor, of course. And frankly, our goal with Zuul is to accommodate all of those. And finally, continuing in that vein, Zuul supports all of the different major cloud systems out there. We've got support for Amazon, Azure, Google, Kubernetes, OpenShift, OpenStack, and more are in the works. So not only can Zuul support talking to these different clouds, once again, it can support talking to these different clouds at the same time. And Zuul jobs are inherently multi-node. So Zuul isn't the kind of system where you just get a container that can run your unit tests. You can do full stack deployment testing with Zuul. So if in order to deploy your system, you need to set up a Kubernetes from the ground up, you can ask one of these clouds for a Kubernetes and deploy your system on it. If you need, say, 3 virtual machines, then ask these clouds for 3 virtual machines. You'll get them, and in Zuul jobs, you can individually address each of those machines and run your job on all of them. So this is great for deployment testing. So it kind of facilitates our vision of bringing continuous integration, continuous deployment, GitOps, DevOps, all under the same umbrella, all with the same software, using the same processes. We like to say that that we want to make testing more like production rather than making production more like testing. So with all of this in mind, I want to talk about speculative execution next, which is really Zuul's. We think that this is one of Zuul's key features, and there's two aspects to this. First is project gating in general, and that is just this. If you look at the diagram on the right, when you're merging changes into a project, the idea is that we sequence those changes, and we test every change in that sequence with the changes ahead of it. And if those changes pass their tests, that's great, they merge. If they fail their test, we move them out of the way. We reschedule the jobs behind them and retest it as if that change wasn't in the sequence anymore. A natural outgrowth of that is this idea of cross-project dependencies. And so if you look at the diagram on the left, that's this idea that you can have a front-end UI change. So say that's in one Git repository, and that depends on a change to a backend server. And perhaps that backend server in turn depends on some library changes. So what Zuul does is it allows you to express the relationship between all of these changes and tell Zuul to test all of these changes together as a unit. And you can verify that that sequences of changes that cross project boundaries, that cross organizational boundaries, are all tested together and work before they're merged. So this is a really key part of how Zuul behaves, and a lot of how people use Zuul kind of develops out of this behavior. So I'm going to turn it over to Mohammed now, who is going to walk through a demo of this concept.
Thanks, Jim. Great. So yeah, what I'm going to do is I'm going to go into a little demo here where I'm going to go through some very basic code. So I'm going to give some context here is that we have, in our case here, both an application and a library. So taking into example that we have an application for our little store that we have that greets individuals when they come to the store. And the good developers that we are, we've decided that we are going to build a library to greet individuals so that we can reuse that library in the future and maybe be helpful for other people that want to use a library like this. So we're going to very easily look at the code quickly. So I mean, all you see is we've got a function that asks to welcome to store, and we're using our little hello library to greet this individual that comes to the store. Now, at the same time here, we've got some tests because we're good developers, and we've got tests to make sure that, I mean, if a customer walks in and we know their name, we're expected to say, hello, Billy. And if we get a customer without their name, we're expected to get a simple hello. Our very simple library that when we kind of go into it here, all we've got is a function that is say hello, and given a name, it'll give the name, and given no name, it'll just say pure hello. So it's very, very straightforward here. It's not exactly the most complex of scenarios that we're trying to publish, but the most important thing is just to get an idea of what we're going to accomplish here. So let's operate with the assumption that a bunch of people got together in a meeting, got into way too many meetings, and decided that from now on we need to ask for the individuals' names when they walk into the store. And finally, you're tasked to do this work. So as a developer, you tell yourself, well, I know that I've got this library that does this, so I'm going to go ahead and make a change to the library. So I'm going to quickly hop in here to make this change and say, you know what, instead of saying hello, I'm going to say, hello, what is your name? And at this point, I did my work. It was a good demo. Let me run my tests as well. As my tests are running, they fail. So I say, okay, wow, my test had failed, right, because I changed the behavior when I'm saying hello to no name. Therefore, my tests are currently failing. So it probably makes sense to fix those tests as well, considering that we've changed the behavior. So that's what we'll do. So hello, what is your name? And we'll run the test again. So our tests are all passing now. So as a developer, we're probably pretty happy. We'll probably do the right thing and be on a separate branch, and I'll call that just demo greeting. And I will push this up to GitHub. Now what we just did, a very simple thing. Copy this. We'll go into here, and I think I forgot to commit. So let's just do that. Fix greeting, and then we'll push. Much easier to not do any commits. If only life was that easy. Okay, so we'll create this pull request. And so now what's going to happen is we're going to look at our files changed. And so we see here that we've made those 2 changes. And Zuul in the background have started to do its job, and it's running the check jobs. So you can view more details and see that it's actually starting to run all these jobs that are queued right now. So those will take a couple minutes so that we don't have to wait through it. We'll do the cooking show trick, and we're going to jump right into a pull request that has the same exact change and look at what the check results are. So we see that the test had actually failed. And why did they fail here? So this job specifically, the Hello App Talks Pi36 job, is actually running the tests of the application using the library change that we just did that hasn't even merged yet. And so what this just signaled to us is while the library tests itself are passing, we've actually just broken our application by making this change. And we can click on this and go into the Zuul logs and notice that it's going to tell us that, well, there's a problem here because the applications tests here are expecting that we're getting hello, but we got hello, what is your name, which is problematic. And, so in a normal scenario, if you're using a normal CI tool, this is the sort of change that would not be caught because you're probably running tests for the project itself, and very rarely is it giving you the ability to run tests for projects that are not actually the ones that are affected by this change. Now, the other kind of thing is, you tell yourself, okay, well, I've got to find a solution for this. The solution for this is another alternative. So, you say, okay, well, so that I don't break the API, I'm going to add an extra flag saying ask and default that to false. And only if ask is set to true, then we are going to say, hello, what is your name? And then we're going to also add a test for that. So again, on the expense of time, we look at the checks and we see that it actually passed with this change. And that's mainly because this is defaulting to false, so it's just going to work naturally out of the box. And so finally, we go back to now we know that we've got a change that works in our library. And if we merge this, we're not going to break our application. But the thing is, we don't know if our application is really going to work once we flip this switch over, because we don't know that yet, because we still are defaulting to ask equals false. So that's one of the really nice things with Zuul is the cross-project dependencies. So this is another pull request that I made where what I did was actually add the ask equals true and change the test to actually expect hello, what is your name? And if you look at the conversation here, I've set up something unique here in the pull request, which I've set up a depends on and then put the PR of the change that included the library fix. And what Zuul does automatically when it notices this is it automatically checks out the library change that is in this pull request, even if it hasn't merged yet, add it to the application tests, and then run all the tests of this application with that change pulled in. And so in this case, if in a normal CI system, if you make this change, it would also break. The only way that this would not break is if you somehow merged the first change or did some sort of release and then tested it after, which is, again, testing is going to test not pre-merge. Like, it's not going to test the future. You're testing after the fact, which is after it's already broken. And if we look at the checks here, we'll see that the tests actually passed. Because what Zuul did was actually check out a version of the library that we had installed. So if we quickly look at the console here, and we see here, we'll see that it actually installed the Hello library from the checked out local copy. And so because of that, it's really, that's kind of like the power here is now you've got this change that tests out a library change that hasn't even merged yet. So what's even more powerful at this point is because Zuul does gating, this change that failed will never be allowed to merge because it's failing. And so that way your application is never going to break because this change can't merge. This change that is with the ask flag can merge because we know it doesn't break the application. But what's also even more interesting is because we've expressed the dependency here with Zuul, this change is not going to merge as long as the dependent change has not merged yet. Because if you think about it, if we merge this change in some way, this ask equals true doesn't actually exist because this other change has not merged yet. But because of this express dependency, Zuul is never going to let this change merge so as long as this other change has not merged yet. And so you kind of have this locking mechanism where you can make sure that nothing is going to be merged that's going to end up breaking code, and you can have things merge in a sequential manner that it's always going to maintain that all the code is always passing all the tests and nothing breaks. So that's essentially an overview of what this sort of power that Zuul gives you to do. And I'll hand it over back to Jim to chat a little bit about how to get started with Zuul. And I hope you enjoyed this demo.
I think just before we get to that, and thank you, Mohammed, that was amazing. We've got John from Texas asking, can Zuul test against projects you aren't an owner or maintainer of, like upstream libraries?
That is a great question. And I also see that Clint has responded to John a little bit. That yes, you can pull in upstream or external, whatever you want to call them, projects as dependencies, but it gets complicated without triggering if you want to test all changes. That's what Clint says, and I think that's spot on. And what this really goes to another one of those continuums, right? And that is sort of the continuum between how isolated you are as a project that depends on another one versus really interacting and collaborating with that other project. And so again, Zuul has several tools here depending on where you fall into that spectrum. If you really have no other relationship with that project, then you're probably just going to be able to pull it in as a dependency and test your code with it. So that way you can make sure that as your project changes and as the other one changes, you'll at least always know that your project is either working or they've done something to break you. You'll find out early on in that case. If you have a closer relationship with that other project, then you may be able to trigger runs of your jobs on changes to that other project. And so that's when the other project would get notification that they're about to do something to break you. And that's a great relationship to have with another project. And we found that I guess in my own experience over the years, I've found that I found myself in various places on the spectrum. Sometimes the my use of another project is minor enough that it doesn't really warrant establishing that relationship with the other project. But other times, you start talking to the maintainers of the other project and you say, hey, I really rely on you, and I want to make sure that you don't do something that breaks me. And they'll say, that's great, because we don't want to merge a change that breaks you either. And you can quite often establish those relationships between projects. So I think really the exciting part about all of this is not only is it a cool technical problem that you can solve with something like Zuul, but it leads to greater cooperation between projects. So it's a real great human factors thing.
Awesome. We have some more questions coming in, but I think we're going to get back to Jim's get started with Zuul piece, and then we will address those questions in the end. So keep them coming.
Great. So if you're interested in getting started with Zuul, there are a number of great options here. We have in our documentations something that we call a quick start. Basically, you can run a Docker Compose setup and get a complete Zuul system up and running in a matter of a couple of seconds. With that up and running, you can sort of start to evolve it to change it to meet your requirements, add your own code review system, start developing your own jobs, that sort of thing. So it's a great way to get started with Zuul and start to evaluate it. And we've got the URL right here on the screen here. If you just go to zulci.org/start, that'll take you right there. There's once you've got a Zuul up and running, there's a standard library of jobs that are developed by people all over the world in various organizations. There is no central there's no one company that's driving Zuul. It's a real community-driven open source project, and as people write jobs that scratch their own itches, they share those jobs with other folks in this sort of standard library of jobs that we have. So you can take advantage of that. That might sort of help you get ahead really quickly. And then finally, there are some commercial offerings here. I have a company called Acme Gating, which focuses on Zuul development and support. So if you want to run a Zuul on-prem and want to would like some help setting that up and support for it, talk to me. And Mohammed, I don't know if you want to talk about your offerings from VexHost.
Yeah, so I guess on another end of the spectrum, if you're kind of more of a company that relies on something that's fully hosted and fully managed, you kind of want it to run somewhere else and consume Zuul as a pure service, that's something that we offer as well. So it usually is running on our cloud and can consume resources on our cloud or on any other cloud that you want it to run on. So we have that available as well if you're interested. And all of these are available on the Get Started link that we've just shared as well.
Excellent. Well, thank you, Mohammed and James. I think we're going to go to a couple more questions here. We've got one from Antoine. He asks, is the depends on recognized in commit messages /PR/pull request summary, or does it have to be added manually as a comment? And I think this is specifically around GitHub.
Yeah, I can comment on this because I thought this was a really good question. Personally, I have a lot more experience with Gerrit and haven't done that much with GitHub. So I was like, let's go and look it up while the stream is still running. And I actually found the documentation for Zuul explicitly mentions this. So I've actually posted it in the chat for Antoine and anybody else that's interested. So it actually talks about, because of for GitHub, it has to be in the PR description. That's what the documentation says. Maybe Jim will say, well, we've changed that. But as far as I know, the dependencies happen on a PR level because The mergeable, you could think like the object that gets merged is a PR in the context of GitHub. And another thing like Gerrit, the context of the blob that gets merged is usually a single commit. And so therefore it works in the footer of a commit message in Gerrit. And so to answer your question, in GitHub, it has to be in the pull request description, whereas in Gerrit, it would be in individual commits message.
Excellent. So another kind of common question we have, circular dependencies. So what if you have two changes and they both depend on each other? How does that work?
This is a really exciting one because for quite some time Zuul did not support this. As Zuul was being developed for the OpenStack project, we kind of had this view that we never wanted to have two changes that depended on each other at the same time. And that's because of the upgrade strategy that we chose for the OpenStack project. Each of those different components needed to be able to upgrade on its own. And so there should always be this way to progress through an upgrade component by component without having to take the entire system down. So we kind of enforced that in the CI system by not supporting circular dependencies. You always had to be able to say you can get from point A to point B one change at a time in sequence. As the Zuul project grew to support other environments, we found that other people didn't have that constraint. In fact, they had the opposite constraint. They said, you know what, we're not upgrading cloud software, we're upgrading embedded firmware inside of an automobile. So this is not something where we actually want to upgrade one thing at a time. We want to ship the entire blob over with all of those changes at once. We need to be able to make those codependent changes together. So Zuul has grown the ability to support circular dependencies, and so basically any kind of graph you can come up with, you can encode that into Zuul. So it's not just two changes that depend on each other. You can grow that to whatever you can manage to fit inside of your head, really. So yeah, that's a great question, and Zuul supports both, and it does so as an option. So we still actually, we set the option in OpenStack to disallow that, so that we can't accidentally get into a situation where we have circular dependencies, and then people who need it, they set the option the other way, and developers go crazy.
So Zuul basically prevents me from hurting myself.
That's the idea.
Perfect. I love it. And so we've got someone else, John from Texas again, this guy. What are the downsides of gating? Why isn't everyone just doing it this way already?
I think the answer is because they haven't watched this live stream yet. But hopefully after this, once they know this exists, they will. So I think there certainly are trade-offs, right? And one of the things that happens when you start gating is it becomes difficult to merge code that is broken. I think that's a feature, and I think that's kind of key to accelerating development within teams and organizations. Is there's this idea of move fast and break things, right? With Zuul, we think that you can move fast without breaking things, and the way to do that is to make sure that everybody on the team can perform their work without stepping on the toes of anybody else, right? And that's what happens when you merge broken code. You merge code that you think works, and it slows somebody else down because they suddenly can't get their work done. So by keeping things green all the time, Zuul helps speed everything up. At least that's been my experience. If you're not used to this, that can be a hard thing to wrap your head around. You might say like, oh, well, what if I just need to merge something, right? Honestly, at the end of the day, that's kind of an organizational question. Like, under what conditions is it okay to just merge something? And I would say that normally you shouldn't be merging things that are broken. Maybe maybe your project gets broken by an external dependency, and it's outside of your control. What do you do then? Well, I mean, there's always escape valves, right? So if that happens and you need to merge a quick fix, sure, there are ways to bypass gating to get something into production really quickly. That's something that you can do. So it's kind of about like what are the norms for the project, that sort of thing. If it's not an emergency and some external dependency breaks my project and that prevents me from merging code, that's okay from my perspective. That's good information for me to know. I have learned that the project is broken. It's unfortunate that it happened, that it couldn't be prevented. It may have been able to be prevented if you establish those relationships that we were talking about with John's question earlier. But stuff happens, and in that case, what do you do? And from my perspective, I want to know that it's broken, and usually what I do is the next change that I merge is the change that fixes that again. So yeah, that's kind of how I see that. I don't know if you have anything to add, Mohammed, from your experience.
Yeah, so I think another thing is I feel like it's probably gating is one of those things that is kind of like a big change and shift in how we do development. It's something that maybe if you're involved in some of the OpenStack communities, it's something we're used to. But I think if you think about it, many years ago, there was no continuous integration. It was everybody pushing to a branch, and then one day a bunch of QA people would go and manually, run some stuff and run through some list of tests and say that everything is okay. And then you would get that thumbs up. And then eventually with time, that transitioned to machines and computers giving you that thumbs up. And so I feel like one of the things is it's just not something that is so widespread yet. So there is kind of a lack of exposure. And I think a lot of people feel concerned, or it's probably like a fear of the unknown, like not really sure about this, never really seen this happen a lot. And it's like this weird feeling of like control over your project. Like I want to be able to merge something when I want to do it. And when I want to do it, I want to do it now. But that potentially, risks slowing things down even more down the line. And yeah, I think also Antoine's comment is really good. I mean, yeah, if there's dependencies that are breaking, fixing the dependencies generally will allow you to keep moving again. But yeah, probably would be nice if you could just, from the get-go, never have these breakages. But, you're going to find out about these breakages, whether you're gating or not. It's just a matter of, will you merge code while your stuff is broken, or will you only, or you merge code all the time?
Sounds like gating is the future, basically.
I think so.
So how do I deploy Zuul? What are the different ways I can do that?
So there's, like I mentioned earlier, there's we've got the quick start, which will get you a Zuul deployed in Docker Compose. So that's a great way to get started. If you can, of course, so Zool is written in Python. You can install that on some virtual machines, just like you would any other Python program. For some of the Zools that I work on, we deploy them in containers on virtual machines. It's kind of a best of both worlds situation, in that we get the atomicity of container upgrades and that sort of thing in an environment where we don't necessarily have access to a Kubernetes or that sort of thing. If you do have a Kubernetes or OpenShift, there are you can deploy it that way. There are Helm charts out there. We have a Zool operator that's a work in progress right now. But if you're really into early adopting and you love Kubernetes, you can jump in and help us with that. So I think those are all great ways of deploying Zool.
Awesome. So Albin asks us, any comments about running reproducible build systems with Zool like Nix or Bazel?
I have a little bit of experience with Bazel. We're actually doing some work in with the Gerrit project for a Zool that helps test changes to Gerrit plugins and things like that, and they use Bazel a lot for their build system, and it's really interesting, and I think it's a really good fit. There's I mean, a key concept in these systems is sort of what is effectively the cache, right? So once you've built something, can you put that thing in the cache and then make sure that you get the same value? You can pull it out of the cache and save time. You can be assured that builds started from the same starting point and things like that. Exploring how that interacts with Zool and its speculative execution is actually really exciting. It's sort of like, what is a reproducible build system and a build cache mean when in a world where you're constantly doing throwaway builds of things that you may not end up merging in the long run? And so far, we're actually coming up with some pretty good answers for that. It's all about identifying, is this build speculative or is it final, right? And so what we're doing with Bazel is saying, well, when this when we complete one of these speculative builds, we'll use the cache to help build that, but we're not going to put the result in the cache until we're sure it's final. But in the gating process, when the underlying change merges, we at that point know that it's safe to put the results into the cache. Effectively the build is finalized, and we can put that in there and then builds after that can use it. We actually take the same approach with Docker containers and things like that. So we're sort of we're always building these speculative Docker containers, and sometimes we even push them up to the registry, but we don't tag them in a finalized way yet until the change merges. So really what I've done is I've twisted this question into, how does gating apply to other systems? And the answer is every system we've worked with so far, we've found a way to integrate it, and it makes sense, and it's really exciting.
That is really exciting. So one question that I've gotten a lot is, what differentiates Zool from just your run-of-the-mill CI? I know you've covered lots today on gating and speculative execution, but aside from those things, what's different? Why Zool?
I'm going to ask if Mohammed wants to answer that. Maybe put a different perspective on things.
Yeah, I think so. For me, I think the biggest points are, first of all, the idea that you have gating for your code. Gating helps merge. You don't merge any broken code, so you don't have any problems with your main branches breaking. As a matter of fact, I always thought it was funny for a while. And I think still the case that how CI tools usually have a cute little icon that says passing or failing, and the Zool one is a static file, because if you got your jobs doing right, it's just always passing. There's no need for us to dynamically determine if it's passing or not, because it's passing. And so that's something to kind of keep in mind of how what Zool kind of provides to you. The second thing I think is the cross-project dependencies is a super powerful tool that allows you to iterate and do work across multiple different repositories to accomplish what you need. And this goes for so many different things, right? You've got scenarios where if you have a repository that contains the configuration of all your systems, and you've got independent repositories containing Ansible roles that you use, well, you can do speculative testing by making a change in a role and then running the tests on the repository that's running your playbooks. We saw an example of a Python library and application. There's other things you can do, such as maybe using something like Terraform and building modules in modules that are all separate and all fully contained on their own, and then consuming them later. There's also some more complex and advanced things that you can do with speculative things, like speculative containers. So building containers that are just not even built yet. Like you make a change in a Docker file, you don't need to publish that somewhere for you to actually make a change for another Docker file that depends on this. It'll automatically go and take care of all of that. So there's a lot of kind of power in that, in being able to allow developers to be more productive without actually having to merge anything. And I think that's another powerful thing, because if you think about it, let's assume in a normal scenario where you've got some more senior people that are doing code review and other folks that are writing code. Well, if you can't start your application change unless your library change is landed, you're kind of having this bottleneck where you constantly need to have a human that goes in and merges that code for you so that you can continue with the rest of your development, which could be pretty distracting for whoever's looking at the code. Whereas with Zool, you can actually start making the library change, make the application change, do a whole bunch of other changes, and then present that as a single unit to be reviewed, and know that all the tests for all of these different components have all passed together without you having to wait for code approval or merging something before it can get done. So I think that's also really powerful. And the one last thing that I'll add up very quickly is the huge library of roles and existing jobs. So because Zool's been around for a while, there's jobs we just talked about, there's jobs for Bazel, there's jobs for Python, jobs for Terraform, jobs for Docker. So there's a lot of pre-existing job libraries that are very well tested and maintained by the community. So at any time you can get a project up to date, up and going really quickly by using those. I think that's mainly the main things.
Yeah, that's awesome. That's a great answer. So I think we just have a few minutes left here. One thing I did want to find out is what's next with Zool?
Well, yeah, that's a great question. We have a lot of work in progress right now. One of the big things that we're focused on at the moment is scaling. Zool is already one of the it's running CI for the the world's third largest open source project. It scales pretty well already, but having said that, we still do have one single point of failure, and we're going to get rid of that. So that'll actually make every component of Zool fault tolerant and scalable. So so we can grow even larger and be even more robust. we've got a project to, so Zool has a built-in secret storage system that you can use on its own, or you can integrate with other secret storage systems. We want to make sure that all of that sensitive data is stored encrypted at rest. And we're working on improving our metrics and logging. So basically, better integration with various monitoring systems and that sort of thing. So a lot of operational stuff right now. We just came off of a release where we did a bunch of new end-user visible features, and so we're trying to kind of back that up with making the system itself more robust and reliable.
That's exciting. It's you always have to do after your big release, you always have to go for the stability. Mm-hmm. That's great. So listen, thanks to both of you for coming out today and for joining us. It's been really interesting. If you're like James and Mohammed and you're supporting an open infrastructure project, we would love to have you join the foundation to continue supporting this community. If you're interested, hit us up at openinfra.dev/join or email me directly at jimmy@openinfra.dev. Next week, we are super excited to host our Open Infrastructure Foundation Chair, Allison Randall. She will be joined by Jonathan Bryce and Mark Collier to answer your toughest questions around hyperscale, public clouds, security, software supply chains. So think hard, make them tough, don't go easy on them. Share your questions with us in advance on all our social media channels, Twitter, Facebook, LinkedIn, MySpace, and definitely join us live to see it all go down. And don't forget, if you have ideas for future episodes, we want to hear from you. Mark your calendars, and I hope you're able to join us next Thursday at 1400 UTC. Thank you again to James and Mohammed for the great conversation today, and we'll see you all on the next Open Infra Live.